Okay, in this lesson today we talk about what to do with these ions that we've been learning about and how are compounds formed. Okay? So we're going to talk about ionic compounds first. Ionic. Okay, now notice this word ionic has the root, how's that? Has the root ion, right? So it's like an ion characteristic compound, okay? And in fact, ionic compounds are created because of the opposite charges of the ions. So you know we've talked about positive ions, which are called what? Cations, okay? Cations. Cations, no, not cations. Cations, yeah. No, cations. Plus, what are the negative ones called? Not anions, no. Yeah, no, it's not anions. It's anions. Okay, real good. Thank you for being difficult. Appreciate that. Really good. Cations and anions. All right. Okay. Well, we'll say cations and anions, okay? Because that's what most of the world does. All right. So if we add these up together, we get a compound. Why? Because the positive charge from the one ion and the negative charge from the other one will attract each other. Okay? Opposites attract. That's the way it is in ion world. Okay? And these guys would form a compound. Now, this title here, all compounds are neutral. So when we write this compound, it looks just like this. This is a really simple chemical equation. It's a synthesis equation because we are synthesizing or making calcium oxide. And notice that compounds like this are always neutral. Okay? That's the first thing. Now let's read here. When ions combine, they form neutral compounds. These formulas are written in the lowest whole number ratios of the ions involved. These lowest whole number ratios are called formula units. An ionic compound is often referred to as a salt. One of the most common ionic compounds is NaCl. That's why we usually refer to it as salt or just table salt. So the salt that you put on your food, NaCl. But there are multiple types of salt made up of different elements. Right, they're neutral because the charges cancel each other out. And even if we have, and you'll see here coming shortly, like this first example here, this one is probably one of the more complicated ones, but it's a good way of explaining how the charges always kind of have to cancel each other out to make a compound. So yeah, so there won't be charges on a neutral compound. When determining the formula for an ionic compound, and this is the chemical formula, determine the charges of each ion, and then be sure to combine them so that the number of positive charges is equal to in magnitude to the number of negative charges. So just what you were noticing, that the charges have to cancel each other out totally. And that's how we know that we're combining them in the right ratio. So for example, aluminum oxide, okay? Let's take a closer look at aluminum oxide. It's made up of aluminum ions, which aluminum has a 3+ charge for its ion. And oxygen ions, or oxide ions, have a 2- charge. Okay? Now, if we just put these together like this, aluminum oxide, if we just did that, AlO, we would find that this would have an overall charge of +1. And now why is that? Because this carries a 3+ charge, this carries a 2- charge, and so see how they're imbalanced? So this, AlO, is not the proper formula for aluminum oxide. Okay? Now, if we have a differing number of charge like this, so 3+ and 2+, then in order for them to balance off, you would have to find some common multiple of 3 and 2, basically, and that is 6. Now, I'm going to show you the way that I like to that I've done this before with students, and it's kind of been a good thing. Aluminum. And you don't have to draw this right now, just kind of watch. Aluminum ion has 3 positives. Now, it doesn't matter, if they're jutting out here for the positive, but this is the way I'm going to do it. Aluminum 3+. And oxygen, which is negative, okay, has this sort of shape, and it's a 2-. Right? And so if we had this right here, and these were kind of to slide together and fit, fit together. You would see that if I move this, and I'll just try and lasso this, move it in, oh, beauty. Okay, so check that out. Now look, this does not look right, and that's why ALO is not the proper formula, because we need to have, like, this little positive charge has nothing to bond with. You know what I'm saying? So this is not quite right. So let's just do that. Now, if I made some copies of this, let's say I have several of these, and where did that go? I have no idea where that just went. It's probably behind the picture somewhere. Okay, let's try it again. There we are. And again. Okay. So, can you see what's going on here? So I'll move this one up here, and I'll move this one up here. Okay? And how many of these would I need? Well, let's grab this one, and let's say we have 2 of these guys. Paste. Alright. Okay, so let's move all these into position. Now these drawings are not perfect, but if we move these into place here, you can kind of see. Oh boy, now I'm in trouble now. I can move this exact one here. Oh, no, my drawings are not perfect, sorry. But you can kind of see how this is going to work, right? It's going to balance off. And so we have a total of 6 plus here. And we have a total of 6 minus here. And so when these numbers are the same, then you have the right combination of positive and negative ions. Okay, like I said, this is one of the tougher ones that they start off with here. But if you can understand this, then you are 90% there. Okay. So aluminum and oxygen combine in such a way that there are actually 2 aluminums, Al, and in a formula we always write the number of ions involved in the compound as a subscript behind the symbol. Right? And oxygen there's 3 of them, so that's why we put a 3 as a subscript here to say, hey, I need 3 of these ions. There's no charges involved. They all should balance off, so there's no overall charge. That's how you get the formula for the compound. Any questions on that? Okay. Now, some of these down here are a little bit easier, I would say, but these are some more examples. Okay, calcium and iodine. So watch this, Ca2 plus iodine 1 minus. That makes calcium iodide. Now we need 2 iodines. Why? Because there's a 2 plus charge for 1 calcium ion and only a 1 minus charge for each iodide ion. So do you see how we would need 2 iodide ions to balance off with that? That's where you get the formula CaI2. The same with Mn. Mn is a 4 plus ion, and oxygen is a 2 minus. So these ones are pretty easy because you can just say, hey, I just need 2 of these, and I don't have to change the number of these. And so that's MnO2. Okay? Yeah, question? Here's an example here that I want to talk about. This one right here. Remember how we had to state ions that have multiple charges? We had to tell which one we were talking about? Well, in this case, when we're naming a compound, you do have to tell which ion was involved in making this compound. So, in this case, copper 1 sulfide is the name of the compound. And that consists of the Cu 1 plus ion and the sulfide ion. Okay, those are the ions that form the compound. Now, to get the proper ratio, you see, we need actually 2 of these guys right here. Okay? And so I'm showing you, I'm displaying for you, modeling for you a chemical reaction as well and how to write a chemical reaction. But because 2 of these ions would have to balance off with 1 of these negative ions, then we have Cu subscript 2 S. And that's the compound for copper 1 sulfide. Well, that's what I'm going to do right now, actually. Copper 2 sulfide. So this is an actual compound as well. And what would the formula be for copper 2 sulfide? Any guesses? Cu2 plus S2 minus. Now, how many of each do we need so that they balance off exactly? Just one of each. So yes, those of you that said CuS, that's the proper formula for copper sulfide. Now, you wouldn't write this. Oh, what about Cu5S5? That works too. They're balanced. Normally you would do the lowest ratio, okay, of the numbers. So that's why we wouldn't put Cu5S5. It's improper because we're talking about a basic kind of formula unit, which would be the simplest ratio here. Okay, CuS. So as we practice these here, let's take a look at this worksheet number 1. It says, write the formulas for the compounds formed from these elements. Remember, the cation is always written first. In a compound, we always write the cation first, okay? In an ionic compound, that's the way we always do it, okay? There are some rules that have really good reasons behind them and some that don't, okay? So that's the way we always do it. Always write the positive one first. So rubidium and iodine. Now, what I would suggest you do is either on top or underneath or somewhere, write the actual ion names first. So rubidium. Rubidium is what charge? Yes, +1. So Rb plus. And iodine is what? I -1, right? Okay. And so if you look at those, it's a 1 plus and a 1 minus. Guess what? The formula is going to be RBI. Done. And how do you name this? Rubidium, you always just say the element name, just like the ion, rubidium ion. Iodide. Rubidium iodide. That's what it's called. Okay? So that is, and you don't have to write this down, but you're going to have to name them in the second part. So that's rubidium iodide. All right? Let's do number 3. Lithium and selenium. That's Li plus. And selenium is Se2 minus. So what is the formula for the neutral compound between these two ions? Li2S. Okay, so how's this? How's that look? Pretty bad. You're right. Why is that bad? What's the issue there? Yeah, this 2, okay, there is a 2 there, but it's not a regular kind of number up there. Like it's a subscript always. So Li2, because we need 2 of these, Se. So that looks better? That's correct. So positive first. Any numbers, like multiples of the ions, have to go as subscripts. Okay, aluminum, oxygen, we did that one already. What about silver and phosphorus? Okay, silver is Ag what? Plus what? Plus, yeah, it's just +1, it's number 47 there. And phosphorus is just P, and what is the charge on phosphorus? 3 negative, yeah. 3 minus charge, 3 negative charge. So, what's the ratio of these now to get to a neutral compound? How many of each do we need? You only have 1 plus here, so you need 3 of those to match up with a 3 minus charge over here. Does everyone see that? So we actually need 3 of those. So the compound then is Ag, positive first, 3 as a subscript, P. And the name of this is, anyone want to guess? No, not phosphorus, silver. You always name the positive first. Silver. Silver what? Silver phosphide. Yes. Silver phosphide. Okay? Is it starting to click? Starting to come or no?
Yeah.
Sort of? We're going to try some from B as well, yes. So B is naming. Naming's pretty easy. The only thing you got to watch for is, do the positive ions, do they have more than one oxidation state, or sorry, more than one charge? Then you have to put the Roman numeral in the name. That's the only thing. But here, cesium and sulfur, right? Those are the two elements. So this is just cesium sulfide. Ionic compounds, pretty easy. Pretty easy to name. You name the positive ion element, and then you replace the "ide" with the negative. Now, this one over here, though, 16. We need to take a look at 16. Let's just finish this thought here. Why do we need to take special consideration with 16? Yes, iron has more than one charge. Now, from this compound, you should be able to tell which ion is being used in this compound. Because there are 3 F minuses. And there's only one iron. So what charge does this one iron carry? Yes. Okay. So from the compound, you can tell which ion is being used. So this is iron 3. Make sure you put your Roman numeral in there. Tell which ion it is. Fluoride. Yeah. UO. The capital in the names is unnecessary. You can lowercase them. All right. So I want you to finish this worksheet. Do as much as you can on this worksheet for Monday.